Okay, now it seems to be working. So for all people who are going to watch, Google Hangout stopped working. This is the answer for number 8. That's the answer for 7B, and this is a problem we sort of looked at. They can pause it. I can't. Okay, so moving on to number 9. All right, guys, quiet down. Number 9A, we have to convert Cartesian coordinates, or convert to Cartesian coordinates and sketch. So for part A, we are given tangent of theta equal to 1. So you won't be given directly polar coordinates with r theta. You'll have to figure it out. And so we are given tangent of theta equal to 1. What should we do? Our goal should be to try to get to x and y. So this is equal to sine of theta divided by cosine of theta equal to 1, right? But we can multiply an r on top and an r on bottom. So it's r sine theta divided by r cosine theta equal to 1, which is y over x equal to 1. So we have the equation y equal to x. That's for 3 points. And then to graph it is 1 point. And that's just a line y equal to x.
That's the easiest answer we'll
Yep. And theta is equal to pi over 4, which I don't believe you need to state though. Part B. R is equal to cosine of theta, cosecant squared theta. Now, this is where you sort of have to be creative and stuff. Okay?
Who doesn't want to be creative and stuff?
If you're ever, can you guys read it clearly? Cosine theta, cosecant squared theta. Okay. So if you're ever given something with trig stuff like this, one thing you can sort of always try to do is convert it to different versions of it. So cosecant squared is r is equal to cosine of theta divided by sine squared theta. Okay. And we know that y is equal to r sine theta, right? So if we are to bring sine to the other side, it looks similar to something like y, and we'll try to work with it. So now we'll have r sine squared theta equal to cosine of theta, right? We still need an r for x to get cosine to an x, but we can see that if we multiply another r by the side, we'll have like y squared. So r sine of theta quantity squared is equal to r cosine of theta. And making the substitution, y squared is equal to x. And that is just this problem. Yes?
In the step where it's r equals cosine over sine squared, we're just going to multiply both of those by r.
Yeah.
Okay.
I wrote everything out. You don't actually need to write everything. You on this they showed this step, or you actually do need double arrows here for this.
Minus 10.
Wait, what were the arrows on the? Okay.
Yeah. On the solution, they showed these 3 steps. They didn't show this step. But. So these are the problems that actually some students might miss because they don't have enough time to think and try to solve it. But this is a math test, so you do have to think.
Daniel, I think it should be a
It's a y squared. If it was a vertical, it'd be y equal to x squared.
There shouldn't be any.
If we have a negative y value, it always leads to a positive x value. So that's why that's the graph for it. Okay, for this problem, we are told that r is equal to 1 plus 2 cosine theta. For A, we have to find the values for theta naught at r equal to 0, comma 0 is less than or equal to theta naught, less than 2 pi. And they tell you this, dy over d theta or x?
It was theta, but you wrote X.
Is it supposed to be theta?
I don't know. Is this 2, huh? It might be D, okay, it might be dx because it's m.
Yeah,
M.
dy dx, we'll go with that,
Oh, yeah.
is equal to where tangent of theta naught and r is equal to 0 at theta naught. This is what they give you. And r prime sine of theta plus r cosine of theta divided by r prime cosine of theta minus r sine of theta. So that's the formula for this one.
They give us all the parts of that, or we?
Yeah, all of this is given, what I have written up here. So for part A, we are told that r is equal to 0, so we can set the equation equal to 0. So we have 1 plus 2 cosine of theta equal to 0. Therefore, cosine of theta equal to negative 1/2. Therefore, what does theta equal? 2 pi over 3 and 4 pi over 3. If you guys can see that. So we found what theta naught is. For part B, find the values of the slope dy dx. Since we did it when r is equal to 0 in this problem, we can just do the tangent of theta equation. So m1 is equal to tangent of 2 pi over 3. That's equal to sine of 2 pi over 3 over cosine of 2 pi over 3, which is equal to the square root of 3 over 2 divided by negative 1/2. So our first slope is negative square root of 3. You guys all see why we use this equation and not this equation?
Well, because for B, they wanted the slope at the.
Yeah, they wanted the slope at when r is equal to 0 at the pole, right? So that's why we use this equation. But for the next problem, we have to use this equation to find the slope. Okay. For this one, we use tangent because it's at the pole. R is equal to 0. But if
So did they just give us the other dy dx confusing? Or is that the?
no, because well, for this problem, it could be like that, but you actually use it in the next problem.
You need to know what you're doing.
Yeah.
They say at the pole, you
yeah.
use the R.
They need to provide you this equation overall for the exam because you can use it in different questions. So then they provided it in this part. But essentially, some students might be confused. Okay, I'm going to raise this one. And then we have another slope. That's the tangent of 4 pi over 3. That's the sine of 4 pi over 3 over cosine of 4 pi over 3, which is negative square root of 3 over 2 divided by negative 1/2. So it's positive square root of 3. And those are our two slopes. That all makes sense. No?
Could you explain? Okay,
Yes.
so are you in part A or are you in part B now?
This is part B. For part A, we're just supposed to find theta at r equal to 0.
Yeah.
Okay? And we set the equation for r equal to 0. So cosine is equal to negative 1/2.
Gotcha.
And that happens at two theta values, 2 pi over 3 and 4 pi over 3. To find our slope, that's our theta value, and we have our r formula, right? If theta was not from the pole where r equal to 0, we use that big equation to find the slope. But since in this problem it's simpler, our r value is equal to 0, theta can just be tangent of theta. I'm sorry, the slope can be tangent of theta. So then we use this equation to find the slope. So that's why slope 1 is equal to tangent of 2 pi over 3, and slope 2 is equal to tangent of 4 pi over 3.
Okay, because your R is 0, you already have the poles.
Yeah, it's a simpler equation at the pole. In the next problem, we don't have that. So, oh, in the class today at 12, they said something about, it was like plus something with a squared in it or something, right?
Yeah.
And someone asked whether we needed to show the actual value of a. I would show it.
You show it.
Yeah.
Okay.
So Parsons said you don't need to, but you never know with the graders. They told in the problem that a is greater than 0. So then the way to simplify this, I would have sort of just done that. So in this case, it'd be whatever, 4 plus 1. And then I'd show that since a is greater than 1, it'd be a positive a. So for those who were in the class at 12. Welcome. Any questions? Or you guys just talk? 11. R is equal to 1 plus 2 cosine of theta again. For part A, they ask us to find dr d theta. What would that be in this case? Negative 2 sine theta. So they tell us on page 10, we have formulas for dy dx. So in this case, theta, r is not equal to 0, it's not at the pole, so we use the longer equation, which is r prime sine of theta plus r cosine of theta divided by r prime cosine of theta minus r sine of theta, and then we pull everything in. So we have negative 2 sine of theta times sine of theta plus 1 plus 2 cosine of theta times cosine of theta divided by negative 2 sine of theta cosine of theta minus 1 plus 2 cosine of theta sine of theta. Do you want me to keep going with it? Or I'll just start with it. So it's just simplifying that. So then we get negative 2 sine squared theta plus 2 cosine squared theta plus cosine of theta divided by negative sine of theta minus 4 sine of theta cosine of theta. So it simplifies to that, and then they tell you where theta is equal to pi over 4. So yeah, for part B, we plug pi over 4 into it. So then we get negative 2 times 1 over square root of 2 squared plus 2 times 1 over square root of 2 squared plus 1 over square root of 2 divided by negative 1 over square root of 2 minus 4 times 1 over square root of 2 times 1 over square root of 2. So then that's equal to those sort of this. Well, that's equal divided by 2, so that's negative 1. That's equal to a 1. So that's plus and minus 1. So on the top, we are left with 1 over square root of 2 divided by negative 1 over square root of 2 minus 2. That's equal to negative 1 divided by 1 plus 2 square root of 2. And then you can multiply square root of 2 and also have this. Plus 2. Or it'd be a 4. So both are accepted. Any questions on this problem? You'll definitely see a problem like this. And that is worth 4 points. Not that much.
They didn't give you no blank spaces.
Are you guys good to move on? Yeah? One thing I will mention, this old exam does not have area problems, and you will definitely be tested on that. So I would redo the problems they did in class today. Those are good examples, and the ones on the videos to get more practice with those. Okay. R is equal to 1 for number 12. 1 plus 2 cosine of theta again. We have to find the alternate equations. Okay. R is equal to negative 1 to the n is the formula with the function theta plus n pi. So in this case, it would be negative 1 to the n of 1 plus 2 cosine of theta plus n pi.
How do you know when to use that equation
Versus the what?
the one where you do
Where it's not a function. There's the,
Where there's no theta in it?
No.
Or the odd and even thing?
there's one
not
that-
even.
Yeah, the odd and even.
Okay. 1 second. I think that's when it's like r squared.
Mhm.
So then you have to work as an odd and even problem. And the number that they did in class number 12, go over that one. If you guys have it in your notes.
How do you know when you do that though?
What?
How do you know when you do that?
I think this one is r squared.
Oh, okay, okay.
So then you can't,
You have to account for the plus and minus.
yeah, it's like that won't really do anything. Negative 1 to the n. Because it's r squared. So then the way they do it is they make a negative r quantity squared equal to it. And then for even, they make theta equal to theta plus n pi. So you guys remember number 12 doing that today? With an odd and even, with alternate equations?
Maybe.
Maybe.
I don't know how.
Okay. That's a good problem to go over. Or try to do it in the homework and see if you can figure it out. So for this one, n is equal to 1. So then you get r equal to -1 times 1 plus 2 cosine of theta plus phi. And I'm not gonna solve it out, but you get up negative. You end up with -1 plus 2 cosine of theta. Yeah.
Could you write the trig identities for the cosine
Yeah.
sine?
Let me write those instead of all. The cosine of a plus b is equal to cosine of a cosine of b minus sine of a sine of b. Correct me if I'm wrong, but I think that's for cosine.
That's right.
And then sine, you will have to look at.
So you just flip the sign, right? And do the minus.
I thought that was
Um,
really good.
yeah.
It's just sine A cosine B plus cosine A. It's just plus. So that's plus.
Sine of a plus b, sine of a cosine of b plus cosine of a sine of b. There you go.
Thank you.
Yep. So that's one equation. N equal to 2, r is equal to 1 times 1 plus 2 cosine of theta plus 2 pi. That ends up being the same thing. So we stop. And then I'm going to do next part on here. So with respect to the pole, what do we look at? What is r? What do we replace r with?
Negative.
R with -r. So then -r is equal to 1 plus 2 cosine of theta. You divide everything by -2. So you end up with r is equal to -1 minus 2 cosine of theta. And that is not the same as original, so it's not symmetric with respect to the pole. The next part is with the x-axis. What do we replace theta with? Negative theta. So then r is equal to 1 plus 2 cosine of negative theta. And since cosine, I believe, is called an even function, it comes out to be the same. So then it is symmetric with respect to the x-axis.
So you just completely ignore the minus. Just
Which minus?
the theta you just.
Well, that's like the property.
Yeah.
Cosine with the negative theta is just cosine of theta. With the sine, you bring the negative outside. So with y-axis, we do both of them. R with -r, theta with negative theta. So it's -r equal to 1 plus 2 cosine of negative theta. And we get the same equation we got for part A. This is equal to -1 minus 2 cosine of theta. So it's not symmetric with respect to the y-axis. Did that all make sense?
So if the equation doesn't work, you get it over again, you just say the it's the same result.
Well, this is for symmetric. If you don't get the same equation, it's not symmetric with respect to that axis.
Okay.
But if you get the same equation up there, that means you found all the alternate equations. So are you guys good with this? I'm gonna bring it down. For number 13, we are given the equation of R2 equaling 1/2, and we have to find all the alternate equations. If n is equal to 1, therefore we'll have, since this doesn't have any theta in it, this theta portion is essentially useless, but we still have a -1 to the n power. And when n is equal to 1, this will become a -1/2. Okay? When n is equal to 2, the -1 will be squared. So we'll still get our original equation back. R2 is equal to 1/2. Same. So we stop here. So this will be our only alternate equation, R2A. Did that make sense? There's no theta in this, so we don't change with respect to theta, but we still go back and forth with the sign. So now let's do the intersections and stuff. So I'm going to erase this now. Okay, so prove that R1 and R2 do or do not intersect. At the pole. If we're looking at the pole, what do we have to consider? R equaling to 0, okay? So for part A1, or R1 equal to 0, we get that's equal to 1 plus 2 cosine of theta. And we did that actually in a very earlier problem. We got cosine of theta equaling to -1/2. Therefore, theta we say is equal to 2 pi over 3 and 4 pi over 3. And R2 equal to 0 would be equal to 1/2. Since that is not possible, R2 means R2 never actually goes to the pole, so they do not intersect.
So what does it have to do to intersect the pole? We have to just have the same.
You need to find a value for theta.
Okay.
Do you guys know if those thetas need to be the same values?
They don't.
They don't? No.
Just for intersect.
Oh, yeah. So pause. Yeah.
Okay, I'm going to move this one. For part B, find the collision points. And we have to find cosine of theta, not theta. What do we set equal to when we try to find collision points? the original equations. So then we have 1/2 equals 1 plus 2 cosine of theta. We subtract the 1, we get minus 1/2 divided by 2 cosine of theta equals negative 1/4. Any questions on that? Oh, this bottom one? Okay. But does the first one make sense? That's when they collide when the original is equal. Yeah. R1 is equal to R2. So then R2, we found, oh, they told us the equation was equal to 1/2. So then 1/2 is equal to, so this is R2, this is R1. Yep.
So collision points are just when the originals equal each other, and then the intersection is when the alternates.
Yeah.
Set equal? Okay.
Alternates with originals, and then I think alternates can equal alternates as well.
Okay.
So I'm gonna, are you good with this one? So they say that you only need one of these, but I'll show both of them. We can say R1 is equal to R2 alternate. Therefore, 1 plus 2 cosine of theta is equal to negative 1/2. You subtract the 1 to the other side, you get negative 3/2 divided by 2. Therefore, cosine of theta is equal to negative 3/4. Questions on that? You divide by 2. And then if we set R1 alternate equal to R2, we get negative 1 plus 2 cosine of theta equal to 1/2. Therefore, cosine of theta, you add the 1 to the other side, so you get now a positive 3/2 divided by 2 is a positive 3/4.
You don't have to show them.
No. Well, they say on here you don't have to show both, but do as much as you can.
I think it's just.
If we did, they said we could do this. Let me do all. What happens if we set those equal? You get 1/4 this way, which is what we got. We got negative 1/4 up there. So on this, the answer sheets, they only show this. But in class, when I asked them setting both alternates to each other, we got, if we do that right now, we get 1/4. But they don't show it on the answer sheet.
That's also another.
I think so. I would stick with these two though. Since like this wasn't on the answer key, so I would stick with these two, but in class, when I asked them, they said we could do this too. Yeah. Yeah. Like the way we did it, but we had a section for the first equation, so that's what they'll do on here. Just like the old exam is posted. That's how they'll do it. Or that's how they'll likely do it.
So they'll probably have us find it.
That is this. That's it for the old exam. But Wait, do you guys have any more questions on this?
Can you like email me and just make sure about that alternate one, the very last one? Like,
Yeah.
why it wasn't included?
Yeah.
Thank you.
Do you know how they cut several of the problems?
What?
Do you know how they cut several of the problems?
The cons. They just put the last couple.
They just cut the conic section.
Yeah, so there's no conic section on this exam that you'll be taking. It's on the old exam though that they gave you. But this doesn't include the area with the surface area, arc length, and there was other problem with the, what?
Can you
Yeah.
run through the, so you run through the formulas for the surface area, like the integral formula, so.
Yeah.
Okay.
I posted the review,
Oh, yeah.
so it is on there.
Okay, cool.
Good job.
Why do they keep dividing these in class all too?
Oh,
Fine, we'll write.
I
They would,
mean,
like, split it in half and then say, let's multiply this by 2. Why not just do the straight out?
yeah, that problem they could have done it straight out, but in most problems it's easier to just multiply by 2, and they wanted to keep that consistent.
So you have to change from 1 to 2. You have to divide angle by 2 to do that.
Well, you have to look at the problem.
Okay.
If you don't want to divide it by 2 and just do the whole thing, go ahead. If you had the limits right. So let me write out the equations if you guys want. The area is equal to integral of 1/2 r squared d theta. That's the formula for that. Arc length is equal to the integral of the derivative, which is equal to r squared plus dr d theta quantity squared d theta. Those are those equations.
Alright. And then surface area is 1/2 2 pi.
The surface of revolution,
Yeah.
so that's a capital one.
2 pi r.
Oh, so surface area and surface of revolution are not the same thing.
It's really just area.
Well, yeah.
Just keep it as area and then make
It's the integral of 2 pi r
this is area.
df.
Surface area revolution is like making a 3D object.
Oh.
So this is real easy shit. Surface
And then
area
that can go in there.
is complicated.
It is just, okay, the surface area and area of revolution. Oh, yeah, area of revolution.
Surface
Yeah,
area
yeah,
of revolution.
yeah. Okay, so
Are you guys good?
Yeah.
Okay.
2 pi r, yes.
Thanks for coming, guys. Yeah, I will be in CP from 6 to 8. If you don't live in CP, you can give them your ID at the desk and still see me.
Just ask you a question.
Yep.
You went over this problem sort of like that was an example. So how would you draw that? So that was -5, or the R is always like 15. So what would I?
It's one distance away from.
So I just put 1 and then do go this way.
Yep.
And that's it. But that would be dotted.
Yep.
I'll draw better on this, but yeah. Hey, I've got a reach interview this week. What should I expect? Because they were really vague about it, and I never really replied.
What are you interviewing for?
They told me it was like between SI, group tutoring,